So, yeah, Johnson again. Hello, guys. Can you see the screen? I placed a document, excuse me, on the screen for you. Can you see it?
Yes.
How are you guys doing? I know you guys are excited about the Thanksgiving. I am too. I like Thanksgiving because of the the family thing that it involves families coming together to eat together and so on and so forth. So there's of course definitely I'm sure you know already. There's no class on Thursday, so our next class after this will be next week, and that should be our last class, I believe, at this Tuesday class. And I saw some of the emails. Some of you sent me email about the makeup already, so I'm gonna respond to that. I'm gonna use this weekend to respond to most of them. Um, so let me start by showing you what you need to do this week after you finish your holiday. Um, let's see. I think I didn't see it anymore. Okay, right here. When you look at my announcement, uh, it's come to 10. Yeah, that's it right here. Yeah, when you look at my announcement for this week, I'm gonna make another one to let everybody know that there's no class on Thursday. You see, we're in the last chapter, basically, regression and correlation, chapter 14, for the regression, simple regression. I think chapter 15 should be correlation, multiple regression. So the only homework to do that now is the homework 10 and your project. I put your project already here in this module. If you click on the module and scroll down, you will see where I place the project right here. And for that project, I put a video showing you the direction, the demonstration, the directions. So if you want to submit it early, fine with me. Um, so watch the video first before you follow the direction from there as you do the project. Again, today we are looking at the final topic, which is correlation and regression. I will we'll cover simple regression today. We're gonna be quick, but it is actually very you're gonna enjoy it because the heavy lifting part of it will be done for you by Excel. So now correlation simply means how a measure of how two variables change together. The variable can be things something like the hours you spend in your studies and your grade, final grade, on a test. So regression is, on the other hand, is a statistical method used to predict the value of one variable based on the value of another variable. So they go hand in hand in a way. Now, there are two main differences between correlation and regression. I want you to take note of that. Two main differences between these two, correlation and regression. Uh, So the first one is that correlation the simply measures the strength and direction of the relationship between the two variables, while regression goes further by using one variable to predict the other variable. Now, correlation does not always imply causation. And what does that mean? It means that it doesn't tell you if one variable actually causes the other one, but it will show you the relationship there. Now, but regression can be used to establish a causal relationship or make prediction. It's not 100%, like a cut truth. I don't know. It's not set in stone, I would say. Let me put it that way. Now, you can use this two concept in many ways. For example, a business owner might want to know whether the volume of sales for a given month is related to the amount of advertisement they made that month. An educator might want to determine whether the number of hours students studied is somehow related to their score on the particular exam. In medical researchers might be interested in something like whether or not age affects somebody's blood pressure, or whether or not COVID-19 vaccine really protect us from the disease, and so on and so forth. So these are the areas we can use correlation and regression. Now, as we do these uh, calculations that involve correlation and regression, we have to take note of two main variables. First one is the dependent variables, otherwise known as the Y variable. Okay. Uh, the dependent variable, or the Y variable, means the variable that the cannot be controlled, by the or manipulated. So the researcher has no control over this variable. For example, yes, you can study if you study things like total grades, total sales. Yes, you can make you can decide to spend $2,000, for example, in advertisement, but you have no control over how many sales that advertisement can generate. You can decide to live healthy lifestyle, eat more of vegetables and fruit and meat, exercise every day. Yes, but the amount of the quantity of also or quality of health you will receive from that, you have no control over it. That is why you can see some people do all those things yet get sick. Some do it, and most people do it and get okay, are more healthy. But the quantity of health that you get, you have no control over that. Something with grade, you can study so hard, but you cannot decide whether your grade will be 95% or 93% or 90%, that kind of thing. You have no control over that. So we call them the dependent variable or Y variable because we cannot control it. Now, the independent variable, S variable, is one that you can control. Yes, you can decide I'm going to spend only $2,000 in advertisement, and you spend that only. You can say I'm going to study only 1 hour a day. You have full control over that. Or I'm going to exercise for only 30 minutes a day. You have full control. So you call it the independent variable or the X variable, which lead us to the main thing we are looking at today, correlation and regression. Let's start with correlation. So under correlation, which we represent with the symbol rho, this symbol we call rho. Under this, we try to get the numerical measure of the degree to which two variables move together. We don't know what rho is, the actual value of rho, but we try to estimate it using a small r, which is called sample correlation coefficient. And it can take different values that range from -1 to +1. You can see from the chart here. I can make -1 means negative correlations when two things go against each other. For example, high speed less time of arrival. So they go, you know, they oppose each other. Or positive correlation, whereby, so in negative correlation, if one variable increases, the other one decreases. So I have given you an example with the high speed and less time to arrive. Yeah, I mean, if you didn't crash the car. Anyway, then zero correlation, it means that the two things are not correlated at all. Then positive one means when one variable increases, the other one increases too. For example, living a healthy lifestyle and having a good health, increasing, or spending more time studying and getting high grades. So in between this negative one to positive one, we have different gradations. Usually, answer might not be exactly positive one or negative one, but might have answer that is close to them. For example, if the answer is close to zero, we say that the variables are weak. The correlation between them is very weak, so we cannot say that one of them causes the other one. But if they appear close to plus one, like 85.85, or to negative one or negative 0.85, then we say that there's a kind of relationship between that. We say that the relationship is strong. For example, let me show you more example here. Look at this chart. 0 to zero point 0.2, we say that the strength of the relationship between the variable is very low. 0.2 to 0.4, we say that it's low. 0.4 to 0.6, there's a moderate relationship, kind of. 0.6 to 0.8 is high moderate, and very high means 0.8 to 1.0. Let's say that we try to figure out, we check the number of hours you study each day for 20 days, and for let's say 5 months, and check your grade on different tests during that time. If your answer is R for R is 0.8, that means it's high, very high. That means just hours of study boosted, you are great. Something like that. Now, we can plot, there's what we call scatter diagram. When we plot both the X and Y variables in a chart. Let's look at this one. See, this is the X and this is the Y. You can see that both of them are trending up. If you put a line of best fit, you can see that they are trending up. For this type of diagram, we say that the variables, the X and Y variables, have a strong positive linear relationship with each other. Can highlight it for you. Strong positive linear relationship between X and Y. You can see it's trending up. When they are in this diagram, looks like this. When they are trending down, okay, call it a scatter plot. A pictorial representation plot of the X and Y variable. You can see that this is trending down. This one should indicates a strong negative linear relationship between X and Y. Example of this one, the first one is positive linear relationship. Can be hours of study. If it's high, if you spend more time studying, then you get a better high grades. Example for this one is they say speed and the speed and arrival time. If your speed is high, assuming that you didn't crash the car, you arrive at your destination faster. High, less. In some cases, there may be no relationship at all. At this one, there's no relationship at all. In that case, it will be scattered. There's no relationship at all. No linear relationship between S and Y. Okay? So other concept we need to know here is what we call the coefficient of determination. The coefficient of determination is a statistical method that explains how much of the variability of a factor can be caused by or explained by its relationship with another factor. I will explain that more when we do an example. Then there's what we call the regression equation, which we use to measure the extent to which a researcher can predict one variable from another variable. So So basically, it shows you use it to measure the extent to which how the dependent variable typically acts when one of the independent variable is changed. Okay, and this is how it looks like. Y equals to BO plus B1X, where BO represents the y-intercept. I'm sure you must have had this from your algebra class. And the X and B1 is the slope. So when doing regression analysis and even correlation, these are the computational formulas we use. Some of them, some use a different formula, but these are the ones we use for the computation. This formula, using them might take you 1 hour to finish one question. Yeah, but it's still so the good news is that we're gonna be using the Excel, and that will reduce our time significantly. In a few matter of minutes, you are done. There's an alternative formula we also use, like this one, giving only the correlation coefficients. Again, it takes a longer time. You have to prepare the charts, different columns for each table, for the table, and then before you can apply this formula. To take you an hour. Yeah, okay. Anyway, let's try an example. Look at this here. It says, in a random sample of n 9 steers, the live weight and the rest weight. Of course, the live weight, the weight of the animal when it is slaughtered before they can now cut it and then bone it. Yeah, remove the bones and then package it. Yeah, that would be the dressed weight. So the dressed weight. Sorry, my mistake. I take that back. The live weight is the weight of the animal after it was slaughtered and have not been boned or skinned or put into packaging. That's the live weight. Now the dress weight will be the weight after it had been slaughtered and then bones were removed, skins were removed, and then they put them in packages before that their packages that you buy from the store. So the weight after it was deboned and everything. So it said that the weight in a random sample of n 9 steers, the live weight and dress weight were recorded. In the table below, we let Y denote the dress weight. This is the dress weight here, Y. And then these are in hundreds of pounds. And S denote the corresponding live weight. So this means this is 4.2 means 420 pounds. 3.8 means 380 pounds. And so on and so on. It says, first it says, draw a scatter plot to represent this data. Explain our results. Then use the sample data to obtain the least square estimate of the regression equation. That means trying to see, they say find the regression equation. Calculate the correlation coefficient R. Calculate the coefficient of determination R squared. Find the dressed weight Y when the live weight is 5.5 versus 550 pounds. Is there a relationship between the dress weight and the live weight? Use alpha 0.05. So let's do this so that you can see how simple it is. Before I do that, does anybody have question in what we have covered so far, guys? Any question for me? Hello, guys, you there? Any question for me?
No questions.
Oh, good. Excellent. Excellent. So let's do. So the first thing is, like, since we are using Excel, is to put this data in Excel. You can type it in, or you can copy it from here. Control C and paste it in Excel. Right here, it's our book we'll be using. Control V. So I'm gonna make this to be okay, it's free right here. I think it's good enough. So if you remember the left side is the live weight and the right side is dress weight. Okay. Okay, so we call this the live weight. This one is the dressed weight. Okay. So I'm gonna bring this up. Okay, good. So I'm gonna make this look good a little bit. Okay, right here, make it bold, and then for this, I'm gonna life weight, dress weight. Okay. Now, you can see it. So let's run do the correction. So we can Excel will give us the results right away. So to get the results, what you're gonna do is to click on data analysis, and then scroll and select the regression. See where you have regression right here. Click on that, and then click OK. You see where you say input Y range. Okay, Y range is dress weight. So click on this and highlight it from here. Okay. Then say input X range. Click on this and put all the X range. So I click on the title when I was putting each of them. So I'm going to check label. It said alpha was 0.05, which is the same as 95% confidence. So I'm going to check this. See, it's 95. So that means your chance of being wrong is 5%, which is the alpha. Okay, now output range, where we want the answer to be placed. I'm going to click here and choose the output range to be below here. Okay. And they also want us to draw the charts. So I'm going to put a line of fit plots. Okay. What else? What else? I think after that it should be good enough. What else? Normal probability plot. I don't need that. So I'm gonna just put okay. Yep. Okay. Yeah, I checked labels. So to have. Let me see why it's doing that. Okay, residual plots. Okay. Regression input that range. Okay, range. Okay, it's saying that I used I put the labels. So I checked labels. So this is a new one. Okay, what I'm gonna do, I'm gonna put them without labels. So I'm gonna close this and go back and close this one. Yeah, normally put labels. Non-numeric range. Okay. Let me see what it's saying there. 4.2. Okay. Okay, I think this should be feed this problem. Okay, data analysis, regression. Everything that here. I'm gonna just change this again from this here. Then this one from this. Yeah, let me see why it's good. So what happened was one of these numbers here was not typed well. So that's why I put it say that. So you can see the result right here. So I corrected it. It was seeing this because it was once on this side. It was saying that it was not, it wasn't a numerical value. So anyway, when I corrected it and click on that OK, it give me this result. So with this result, and it give me the charts here, dress weight and life weight. So with this, we can now answer the questions. You can see the R correlation. You can see the R square, the coefficient of determination. You can see the ANOVA table for this. And we're not using the ANOVA table. We're going to use the ANOVA table. I will show you how to use this. And then we need this one too, where we can use this one to get our equation of the regression line. Let's start with the first question they asked us. The first question was to draw the scatter plot. Say, draw the scatter plot. So I'm going to do it right here. Solution. Part A. It already gave us a scatter plot. And I'm going to pull it from this place. Okay. See the dress weight and life weight plots. So I'm going to click on it. Control C, copy it, and then paste it in the this place in my main workbook. Okay. Can see the scatter plot. So you can see it plotted right here. See, it's trending up, but a little bit, right? So interpretation of this. Interpretation. So you can see that it is trending up a little bit, going up. See, going up. So it showed that, I mean, there's a relationship between the dress weight and protein, but it's a weak relationship, according to the scatter plot. This shows, I'll call it medium, shows a mid, I would say weak, because it wasn't like too vertical, like that we're expected it to be. Linear relationship between the live weight and the dress weight. The live weight, which is the X variable, and the dress weight, which is the Y variable. Okay? There is a linear relationship between the two, but it's not very strong, because based on this chart. Okay? Now, that's the first question. The second question was to use the sample data to obtain the least square estimate of the regression equation. Okay, good. Now, remember, the regression equation is written in this form. Y equals to BO plus B1X. That's part B. Oh, excuse me. Y equals to BO plus B1X, where BO is the intercept and the B1 is the slope. So based on this, our BO, you can get it from the table, from Excel. We have our BO equals, and our B1 B1 equals small one, not upper, this is small, okay, B sub 1. So we get it from the our results. So let me write them down. And let's go back to take it as so we can get the result for B on B1. So our BO okay. You can see our BO and B1 right here. Let me highlight them. See, this is BO, we highlighted yellow, and B1, I'm gonna highlight it green. Oh, excuse me, sorry. Yep, green. So let me make them to be 3 decimal places. Oh, excuse me, make it 2 decimal places. You can make it 2. Doesn't depend on what the question says. So our intercept is our BO. So our BO equals 0.256. And our B1 equals 1.472. Okay. Let's go and put it in the workbook and then get the regression equation. Okay. BO is 0.256. B1 is is 1.472. So that's put this, if we put this in this formula here, we get our regression equation as y equals 0.256 plus 1.472 x. That's our regression equation right there. Okay. Now, any questions so far, guys? Any question? Okay. So no question. So what does this equation mean? What interpretation. Interpretation. Okay. So if you look at the slope, 1.472, it means that, remember, these are in hundreds, right? Like 4.2 is 420, 2.8 is 280. So they're in hundreds. So this is like it's a to interpret this slope, and it's a positive slope. That means it show an increase. So it means that the dress weight increases over time at the rate of 1.472 pounds for each 1 pound increase in the life weight. Okay, so given that this is so that's what, because it's positive. If it's negative, that means that the dress weight decreases by 1.472 pounds for each 1 pound increase in the life weight. So, but this time is positive, so it's increasing. So you can see this. The dressed weight y. Oh, sorry. The slope of 1.472 implies that the dress weight increases over time at the rate of 1.472 pounds for each 1 pound increase in the life weight. That's it. Now, like I explained, if this is a negative slope, like if let's say it's negative 1.46, so don't that changes this increase or decrease. If negative, just put decrease here, and that's it. That takes care of it. Sorry, my mistake. Yeah, it is increased, but this part is increased. Not, I'm talking about this one. Increase here is increase. If it's a negative slope, put decrease here instead of increase, and that's it. So that answer part 2, part B of this. Now, part C says, calculate the correlation coefficient R. Okay, you can do that. Part C is already done for us, as a matter of fact. The Excel have already done it. We just go there and pick the answer from there. So this give us, go to Excel is right here, R. Multiple correlation R. I want to highlight it. See 0.95. So I'm going to make it create a smart place. 0.953. So our R is 0.953. Okay. So we go back and put it right there. R equals, we call it correlation coefficient. Coefficient R equals 0.953. So interestingly, this shows a strong positive linear relationship between X and Y, there's life rate and rest rate, even though that means this shows, this maybe the scale they use for this diagram that made it look so you know as if it is a weak relationship. But this one should the arrow say that it's 0.953, which is strong positive linear relationship between the uh, dress weight and the life weight. So means here. I mean, interpret it. The correlation coefficient of R equals 0.953 shows or indicates a strong positive linear relationship between the dress weight and the live weight X and the breast weight Y. See? That's what it means. Which means that as the live weight increases, dress weight increases. If this answer is negative 0.953, that means it shows a strong negative linear relationship. But here is positive, so it's a strong positive linear relationship. Now, you answered the main question. Well, three questions there. So how many is left? We have part D. Say calculate the coefficient of determination R squared. So it's again, it has been done for us. Okay. R squared is right here. You can see it right here. R squared. So I'm gonna highlight it green, light green. You say 0.902. Basically, R squared means you square this R. So, but it's done already for us. So I'm gonna make it again, create decimal places. So 0.907 R squared 0.907. Okay. So I've got it. I'm gonna copy it. Let's go and put it that in our main workbook. So part D, excuse me. The coefficient of determination is R squared equals 0.97, 0.907. I'm gonna edit this, make it R squared. Make it a little bit bigger. So that's what it is. What does this mean? It means that 90.7% of the change of the increase in the because the arrow shows us slope shows us is a positive slope, so it's gonna be increase. If it's negative slope, it's gonna be decrease. So you said 90.7% of the increase in the dress weight is explained by the increase in live weight. Okay. A general way of saying is that 90.7% of the change in the y variable is caused by the change in the x variable. If it is a positive slope, if it's a negative slope, you say 90%, 90.7% of the decrease in the dress weight is explained by the increase in the live weight if it is a negative slope. But this one is a positive slope, or if it's a negative R. So interpretation, you can put it this way. The increase in the sorry, let me put it the best way. About the coefficient of determination showed that about 90.7% of the increase in breast weight is explained by the increase in the life weight. Okay? Yeah, that's it. So, any question, guys, before we round up this? Any question? Okay, no question. Good. Now, next is the it says find the dressed weight y when the life weight is x equals to 5.5. 5.5 x. Okay. We can do that by using the regression equation. I'm gonna copy it from here. Okay. So you can paste it here and use it. But E. Yep. Okay. So when the life weight x equals 5.5. Okay. Okay. The dress weight will be the dress weight will be okay. I'm gonna use this to find it. Just put in the 5.5 for x here. So we're gonna have it in this form. Okay, again. So I'm gonna put for x, I'm gonna put 5.5. 5.5. And that will give us the answer. So let me write them down and we can get it from the calculator. Okay. Y equals 0.256 plus 1.472 times 5.5. Okay. So let's go and get it from the calculator. So we got 0. I hope you can see the screen. Yeah, you can see it. 0.256 plus 1.472 times 5.5. The 8.35. So double checking. Let me double check this with yeah, that's for 8.35. Okay. Answer the 8.35. 8.35. That's what we got. Let me see. Approximately 8.35. Yes. Okay. So answer that. The last question there they asked here was is there a relationship between the dress weight and the life weight? For that, we need to make a hypothesis, and we can use the I think this is the question number F. We use the p-value method to answer it. So we just finished a topic on test hypothesis. So we make a hypothesis here. First of all, a hypothesis will be in this case HO and H1. HO is not hypothesis, as you know already. That would be X dressed weight X. Oh, live weight X. Okay. And dressed weight Y are not linearly related. Okay. So that the hypothesis will say the opposite of that. I'm just gonna put it right there. Just are linearly related. Life weight and dress weight are linearly related. And they say use the alpha. What alpha they want us to use? They say use alpha 0.05. I'm going to copy it from here. And alpha 0.05. You can write it here. Alpha 0.05. So now let's see what our p-value is. P-value equals I make this sense to be 18. Let's see what our p-value is. Okay, go to Excel and see our p-value. So you can see this p-value right here for the address weight. Right here, you can see right here. 0. If you look at this, they put it in a scientific format. But this means you wrote e to the power e negative 0.5. That means 7.33 times 10 to the power negative 5. That means there's going to be 5 zeros before you get the first significant number here. So it may gonna be 0.000733. Right? 0.000, because you say e negative 0.05 means 0.00050 before you can get the first significant digit, which is 7. So we have the p-value right here. So I'm gonna put p-value. 0.0007. Actually, I think it's 733, right? Let me make sure. I just wanted to stop at 7. So yeah, 733. If you like, I can write it that way. Okay. 733. Which is basically 0.000. If you round it to 4 decimal place, it's gonna be 0.01. Now, this p-value is less than the alpha. If you remember, when this p-value is less than alpha, we reject null hypothesis. So conclusion, basically decision. This come under decision. As a matter of fact, decision. So since p-value is less than the alpha, we reject the null hypothesis because the p-value is less than alpha. The p-value of 0.0001 is less than the alpha of 0.05. So the chance to reject the hypothesis. So what does that mean? It means that this is wrong. So this one is the correct one. That the dress weight, life weight, and the dress weight are linearly related. So you can write it here. Conclusion: conclusion becomes the dress weight, the live weight, and the drive and the dressed weight are linearly related. Okay, that's our conclusion. Now, if you want to use the critical value method to answer this, then you look at this table here, the ANOVA table. You can see that the significance is this is the calculated F68.51. This is the significance, which is the 7.33 times 10 to the power negative 5. Say, only 0.00. So in this case, when the calculated value is bigger than the critical value, you reject. So here, the calculated answer is bigger than this critical value. You still reject, no hypothesis. And our answer will still be, final conclusion will still be the same, which is that since we rejected the null hypothesis, we are accepting this one. No, we take the second one, the alternative. So which means that the life weight and dress weight are also linearly related. So any question, guys? Any question? Hello, guys, can you hear me? Any question? Hello,
No.
No question.
no question. Okay, guys, enjoy your Thanksgiving. I'll see you next week, Tuesday, okay?
All right. Have a great day, Professor.
You too.
Enjoy the
Bye-bye.
rest of your week.
Oh, you too.
Happy Thanksgiving.
Happy Thanksgiving, sir. All right, guys. You have nice Thanksgiving.